Welcome everyone to this section on group by. In this section, we're going to be discussing group by and aggregate functions. Group by is a SQL statement that will allow us to aggregate data and apply functions to better understand how data is distributed per category. In this section, we're first going to begin by discussing aggregate functions without any group by applications. Then, we'll learn about group by. With part 1, we'll just discuss the theory behind it. And then in part 2, we'll actually show you some implementation of group by statements in PgAdmin with PGSQL. Then we'll have some challenge tasks for you to solve with group by. Then we'll discuss the having call, which is going to allow for filtering in conjunction with a group by statement. And then we'll have some challenge tasks to make sure you understood the having statement. Let's get started. I'll see you at the next lecture. Welcome back, everyone. Before we discuss group by operations, we should understand aggregate functions in general. SQL provides a variety of aggregate functions, and PostgreSQL is no exception to that. And all the functions we see here are available in any major SQL engine. The main idea behind an aggregate function is to take multiple inputs and return a single output. Now, PostgreSQL provides many different types of aggregate functions, and you can check out the link in this slide in order to go to the official documentation page, but we're just going to discuss the most common aggregation functions in this particular lecture. The most common aggregate functions are average, which returns the average value or mean value. There's count, which we're actually already familiar with. It returns the number of values or rows returned. Then there's max and min, which return maximum and minimum respectively. And then there's sum, which returns the sum of all the values. So it adds everything up in that particular column. Keep in mind that aggregate function calls happen only in the select clause or the having clause. We don't know about the having clause quite yet, but we're going to learn about it later on in this section. Some special notes to keep in mind for certain particular aggregate functions is the average call returns a floating point value many decimal places long. So for example, it could be something like 2.342418, etc. And you can use the round function on top of average to specify precision after the decimal. So we'll see that in this particular lecture. And keep in mind that count simply returns the number of rows, which means by convention we could just use count asterisk in order to see the number of rows. We can either pass in a specific column or just an asterisk since it's essentially the same thing. But we've already discussed that before. Let's go ahead and see some examples of aggregate functions in our own database. I'm going to head over to PgAdmin now. All right, let's begin by exploring the film table since we'll be using that. So we'll say select everything from film. And if we run this, we can see we have a film ID, title, description, and then release year, language ID, and we also have this replacement cost. Notice we have several values here. Let's imagine right off the bat, I wanted to know what the minimum replacement cost was. Well, what I could do is call my aggregate function, and then I'm going to call parentheses, since this is a function call, and I call it on that column, replacement cost. And when I run this, it's going to return back the minimum replacement cost. So at a minimum, we're going to have to spend $9.99 to replace a certain film. Now that also means certain films are more expensive. So maybe we have a budgeting question asking what's the most we can expect to pay to replace a film. In that case, we can just call max and figure out the maximum replacement cost. So the maximum replacement cost now reported back is $29.99. So that is the min and max function, pretty self-explanatory, and you can call them just on any column here. Keep in mind, if we were to try to call something else, like let's say I also wanted to call a film ID column for some reason, that doesn't really make sense. And the reason for that is we're just actually calling an aggregate function on a column, which means max replacement cost just returns a single value. So it doesn't really make sense to call another column with this. In order to call other columns, we'll have to learn about the group by statement, which is coming up next. So keep that in mind. When you're doing just simple calls or queries like this, where we want to figure out the min or max, it doesn't really make sense to call other columns there, since we're aggregating a bunch of values to just a single value. What you could do is something like min replacement cost from film, and we run this, and that works. And the reason this works is because that function, maximum, and this function, minimum, are both returning a singular value. So this will be the max and min for your replacement costs. So keep in mind, because those rows happen to match up, that sort of query makes sense. Okay, let's explore the other aggregate functions we talked about. We're already familiar with count, which is essentially just counting the number of rows returned. So we can say select count and asterisk, run that, and that returns back how many rows we have. So we have 1,000 films. And keep in mind, this works on any column. So we could also say film ID, and that's essentially the same thing. Since that's the case, by convention, we typically just write an asterisk there. And we're already familiar with count. Let's imagine we wanted to know the average replacement cost. What I could do is say average replacement cost, run that, and that's going to grab the mean or average from the film table. However, you probably noticed it looks a little strange here, and that's because by default, this average call gives you a lot of significant digits. So if we expand this column, notice how I'm stretching it out here, we can see that it's actually 19.984 and then a bunch of zeros. So realistically, you probably don't want all these significant digits past the decimal point. So what we can do is wrap this around with a round function, and the round function actually takes in two parameters. One is the value you actually want to round, and then we're going to put a comma here and how many decimal places we want to round it to. So we'll say to 2 decimal places. And this is essentially a mathematical call on this result. So it's going to take this result and then round it to just 2 places past the decimal. And then when I run this, notice I get back $19.98 as the average replacement cost from the film. And we can always edit this if for some reason we wanted 3 decimal places. We can run that and it keeps going. If I said 4, as you may have guessed, it'll start including the 0. So you can either stretch out this column to see all the results if you don't have that rounding call, or realistically, you're probably going to want to round this to some degree. Again, notice how round uses parentheses in order to organize its parameters or its inputs. Here we have the input that we're trying to round, and then the second parameter is how many decimal places. So we discussed average, count, max, and min, and then we finally have sum, which is going to sum all the values in a column. So what does that actually mean? If we take a look at our table again, select everything from film, let's imagine for some reason we had to replace every single film. So we were opening a duplicate store and had to replace every single film. So we needed to figure out the total sum of the replacement cost column. What we can do is say sum replacement cost. We run this, and it would cost us $19,984 to replace all those movies. And if we think about this value for a second, it actually makes perfect sense. Recall that when we were taking the average replacement cost, it was 19.984. And here, we're replacing 1,000 movies with the average replacement cost, so which means the sum of the replacement cost should equal the average times the actual amount of movies we have. So that's essentially 19.984 times 1,000 movies, which means, again, the total cost to replace all the films would be $19,984. All right, so those are the aggregate functions by themselves. That's average, count, max, min, and sum. You can hit the slides and check out the link for more complex aggregate functions, some of them which we will go over in later lectures. But right now, these are really the most common ones you should know right off the bat. And coming up next, we're going to see how we can use this in conjunction with group by to create very powerful queries. I'll see you at the next lecture. Welcome back, everyone, to part 1 of our lecture series of group by. Group by allows us to aggregate columns per some category. Let's first explore this idea with a simple example, and then we'll go over the SQL syntax. Let's imagine we have the following table. We have some sort of category column. Here we have A's, B's, and C's, and then some data value associated with them, such as 10, 5, 2, etc. We can imagine that maybe the category here stands for some sort of company, and the data value is how much we sold to that company. So we had one deal of $10 for company A, later on we had a $5 deal for company A, then a $2 deal for company B, and so on. So when we're actually performing a group by, there's a couple of key things to consider. The first is this category column. We need to choose a categorical column to perform the group by on. That is to say, categorical columns are non-continuous. or at least we're treating them as non-continuous for the sake of the group by. Now, something to keep in mind is these can actually still be numerical, such as cabin class categories on a ship, class 1, 2, 3, and so on. And you should also keep in mind that they actually may appear continuous, but you could treat them as a category. For example, if you recall to our DVD rental database, we have different rental rates available, such as 99 cents, $1.99, $2.99, etc. We could treat each of those rental rates as its own separate class or own separate category. So just because something is being treated as categorical doesn't necessarily mean it's non-numeric. And we're going to see different examples of that in the next lecture when we actually program out in SQL some group by statements. But let's first go through the idea of what a group by actually does and how it relates to aggregate function calls. So the way a group by operates is the following. We have already chosen our categorical column. Then what we're going to do is essentially split this table up on a per category basis. So we have everything that went with category A, then B, then C. And then we have the corresponding data values. Recall that an aggregate function takes in multiple values and reduces them back down to one single value, such as the sum function can take in all these values per category or grouped by category and then return back their sum. So the total sum of sales to category A was 15, 6 to B, and then 18 to C. And we could do this with any of the aggregate functions that we just learned about. For example, we could take the average data value per category, 7.5, 3, and 9. We can even do something like a count per category. In this case, there was 2 rows per category, so they're all the same, 2, 2, and 2. So let's actually explore the general syntax. So the most basic group by call looks like this. We select some sort of category column or something we've deemed to be categorical, and then we choose to perform some aggregate function on the data column. So AGG here is just some placeholder for some aggregate function on some data column. We select it from the table, and then immediately after that, we call group by that category column. So the group by clause must appear right after a from statement or right after a where statement. So if you want, before you do the group by, you can filter things out using a where statement. So here we see just grouping everything together by the category. But if we wanted to, before we actually execute that group by, we could have done a where statement, essentially saying something like where category column is not equal to A, essentially ignoring all the A categories before we went ahead and did the group by. So the thing to keep in mind is the group by either has to come directly after a from statement or directly after a where statement. Now, one of the most important things to realize when learning about group by is the following. In the actual select statement, columns must either have an aggregate function call on them or be themselves in the group by call. So what does that actually mean? This is where beginners often get tripped up in learning about group by, so pay close attention to this one. So if we're using a group by statement, then if we're selecting that particular column just by itself, it must be included in the group by statement. So notice here, I've decided to select the category column, then that particular column must also appear in the group by statement. The only exception to this is if I'm calling some sort of aggregate function on the column itself. So in this case, because I'm aggregating something on the data column, it does not need to be included in the group by statement. So let's imagine a different example. We can have something like select company, division, and then sum of sales. So we can imagine we had 3 columns in this table. One were different companies, and then the divisions within that company, and then different sales per division per company. So what we're doing here is, again, notice that if I'm selecting a column, such as company and division, then they must also appear in the group by statement. So that means we can group by multiple columns, and we essentially just decide the order to group by, in a very similar fashion that we decided the ordering of different columns when we learned about the order by statement. So again, here I'm selecting column and division. Since they don't have an aggregate function, they must appear in the group by clause. Notice again, the sales doesn't appear in the group by statement, which means it must have an aggregate function associated with it. So essentially what this is returning is the total sum of sales per division per company. And keep in mind that the where statements should not refer to the aggregation result. So you shouldn't be trying to do any filtering using a where statement on sum of sales in this case. Later on, we are going to learn how to do that using the having statement to filter on those results. But for right now, if you are using a where statement in conjunction with a group by, that where statement shouldn't make a reference to what is being aggregated, such as sum of sales. That is what the having statement is for, that we're going to learn about later. So notice what we're doing here is we're saying select company division sum of sales from finance table, where division is in marketing and transport, essentially filtering out the divisions before we actually perform the group by on the company and division. And again, notice here, company and division appear in the group by, sales does not because it has the aggregate function associated with it. Here's another example that if you want to sort the results based on the aggregate, you have to make sure to reference the entire function. So in a simpler example here, let's say we wanted to sum the sales, total sales per company. Then we could select company, sum of those sales from the table. We would group by company. And then the other thing to notice here is if I actually wanted to order by the sum of sales, I don't just say order by sales, I have to say order by the sum of sales. So notice that whatever I'm ordering by, that total statement should exist somewhere in that select clause. And then you could add something like limit 5, which would essentially show you kind of the top 5 sales or bottom 5 sales, depending if you did ascending or descending order per company. All right, so I know we just went over a lot of this, and it's best learned through practice. So I'll see you in part 2 in the next lecture, where we actually practice on our own DVD rental database. I'll see you there. Welcome everyone to part 2 of our lecture series on the group by statement. Let's go ahead and jump to our database and work through some group by examples so we can actually build in some practice into creating a query that would work with a group by clause. I'm going to head straight to PgAdmin. Alright, here I am at PgAdmin. First what I'm going to do is explore the payment table. I'm going to do this just by saying select everything from the payment table. Typically we wouldn't do this, but since we have a small table here, it's not so bad to just explore it. It looks like the payment table, we have a payment ID, so it's a unique identifier per each payment. Then we have a customer ID. So notice here, it's categorical. So even though this is a number, this is essentially the actual customer ID. So this is customer 341, and you can see he's visited multiple times and rented out multiple things. And he had different interactions with different staff. So we also have a staff ID, which is also a numeric, but we can treat it as a class. Since it's a kind of a category here, we can think of this almost as the name of the staff person. In the same way we can think of customer ID as here we have kind of a named identifier per customer. Then we have the rental ID here, essentially what movie was actually rented. Later on we'll learn how to join this rental ID column to the actual film column to see what actual film is being rented. And then we have the amount on that particular transaction as well as the payment date. So let's do the simplest group by possible, which is to group together the actual customer IDs. So what does that actually mean? Well, I could say select customer ID from payment, group by customer ID. So if I run this, this is actually essentially the same thing as selecting the distinct customer IDs. This is a bit of a roundabout way to go about it, but if you think what we're doing here, we're just kind of aggregating all the customer IDs together. And we're not performing any aggregate functions on any other columns, so we just get this list of customer IDs. And if I wanted to, I could add an order by statement here to order by that same column, and essentially I just get the customer IDs here that we have in the payment table in order. So nothing too crazy here, and this is not a typical use case for group by, but it's the simplest group by possible of just selecting the column and then grouping by it, which is actually the same as essentially selecting the distinct values of that column. What's probably more helpful is to do this in conjunction with an aggregate function on another column. Let's imagine I wanted to answer the question, what customer is spending the most money in total? Well, what I could do is take the sum of the amount column in conjunction with grouping by customer ID. So if I run this, I can now see the total sum that every customer spent. And then if I wanted to actually order this, I would say order by, and I can't just say order by amount, I have to say order by the sum amount, since that is truly what this column is. It's not just the amount column, it's a total sum of the amount column per customer ID. And a lot of times that the word per really helps beginners understand what the group by is doing. So I can read this as the total sum amount per customer ID. And I'm going to run this, and now I can see this is in order. And we can change it from ascending to descending if we want with ASC or DESC. And this is a very typical SQL query that is using group by to answer a real question. What customer ID is actually spending the most amount of money? And we can do other things like actually count the number of transactions they're having. So I could do something like this. Instead of actually saying take the sum of the amounts, actually just count how many transactions they're having. So notice here the difference in the question. Sum is asking for the total amount of dollars being transacted. Count is just how many transactions are occurring. So when I run this, I can see the count here with customer number ID 148 having 45 total transactions. Okay. Now what we can also do here is use group by on multiple columns. So we discussed this, but let's go ahead and see it in practice. I'm going to first quickly show you the entire table again so we can get an idea of it. So again, we have that payment ID, customer ID. Notice there's also a staff ID. So what I could start to explore is grouping by customer ID and then grouping by staff ID, or grouping by staff ID and then grouping by customer ID. So let's go ahead and show you an example of that. I'm going to say select customer ID, staff ID, and then some amount. And I'm going to group by staff ID and then customer ID. So if I just run this, what's happening here is it's telling me the total amount spent per staff per customer. So that means customer number 1 spent $60.85 with the staff ID person number 1. And what I could do if I wanted to is order by the customer ID. So when I run this, I can now essentially see how much each customer spent with each staff member. So in this case, it looks like customer 1 spent $60.85 with staff ID number 1, and then $53.85 with staff ID number 2. Something to keep in mind here is while the group by order does matter as far as how you're grouping things together, the actual select statement, that order doesn't really matter. So I could, if I wanted to, organize the results by staff ID first, and then by customer ID. So if we just see those results, I'll go ahead and remove the order by just so we can see those raw results here. But here, I'm essentially not changing any information. So we still see staff ID, customer ID, and then the total sum per customer. And then if you wanted to, you could either order by staff ID, run that, and I can see all the ones here. And then we could kind of do a sub-ordering by customer ID. And so I can see staff ID 1, and then it's transactions with 1. Staff ID 1 is transactions with 2, etc. Or I could order by customer ID, run that, and now notice I see customer ID is ordered, but it's ordered and centered here in the middle. So keep that in mind. All of these are essentially showing you the same information, but it's up to you how you actually want to display it. So most often, you're going to actually select things in the same order that you're grouping by in. So keep that in mind. And then ordering by, it's up to you depending on what kind of question you're trying to answer. So we could have also said order by sum on the amount column, run that, and we get back these results. You can order by any of these 3 columns or multiple columns. But the main thing to note here is that I can group by multiple columns. Okay. The last thing I want to point out, and we will learn about this in much more detail later, is when you do a group by on a date column. So if we take a look at select everything from payment, notice that we had a payment date, which was a timestamp. Because it's a timestamp, it not just has the date information, but the time as well. So it has the hour, the minutes, the seconds, etc. So if we actually want to perform a group by a date, we have to call a specialized date function to convert the timestamp to a date, and then we can actually group by that. So what I'm going to show you is that function first. We can say select date from payment date, and we will learn a lot more about dealing with timestamps later on. But if we just run this, we can expand this column, and notice here, it's essentially just filtered out the actual date. It's removed that timestamp information, which makes sense because we don't want to group by every single transaction per minute. What we probably want to do is just group by day. So I'm going to say select the date on the actual payment date timestamp, which is essentially just the day from payment, and then let's go ahead and group by date payment date. If I run this, this is essentially just returning back the distinct dates, but maybe I want to figure out how much is actually being processed each day. So I could take the sum of the amount column, run that as well, and then maybe I want to order by the actual sum amount column, run that, and I can see the days where we're having the least amount in total dollar transactions, or depending how I sort this, if I sort it in descending order, I can see the dates that we're having the most in dollar transactions. Again, what this date function is doing is it's extracting just the day portion from that timestamp information. Because if you just said group by payment date, the main thing to keep in mind is I don't want to just group by that payment date because it was a timestamp information down to the sub-second, which means I would essentially almost have a unique category per payment, which isn't terribly useful. However, we did have multiple payments on the same day, which is why I'm using date to extract just the actual year, month, and day information from payment date, which then means I can group by that. All right, so we've seen a couple of examples here already with using group by. What I want to do is give you a couple of challenge tasks, and these challenge tasks are probably going to be a bit harder than what you've encountered before because we are making a bit more of a leap in learning about group by as far as what operations and queries we are now capable of. So keep that in mind. These challenges won't be as simple as the ones we saw before, but hopefully they give you a good run for your money. All right, I'll see you at the next lecture where we present the group by challenges. Welcome back everyone to this lecture for your challenge tasks for the group by section of the course. As always, we'll have the challenge presented, then the expected result. We'll give you hints if you need them, and then we'll go over the solution. Your first challenge task goes as follows. We have two staff members with staff IDs 1 and 2. We want to give a bonus to the staff member that handled the most payments. Most in terms of number of payments processed, not total dollar amount. So, how many payments did each staff member handle and who gets the bonus? Here's the expected result. So the expected result is that staff ID member number 2 handled 7,304 payments, which was more than staff ID number 1. So staff ID number 2 should get the bonus. Here's some hints. So the hints are to use the payment table and to make sure you understand the difference between count and sum, since only one of them should be working here. All right, and here's the solution. The solution is to select staff ID column, comma, and then count the amount column, or really any column, and then we'll say from the payment table, group by staff ID. And as I mentioned, you can technically pass in an asterisk there since we're really just counting the rows per staff member. Since each row in the payment table represents a payment and we're assigning the bonus based off the total number of payments, we just count the total number of rows associated per staff ID. All right, so let's move on to the next challenge. Corporate headquarters is conducting a study on the relationship between replacement cost and the movie's MPAA rating, that is to say, its rating of G, PG, R, etc. What is the average replacement cost per MPAA rating? Note, you may need to expand the average column to view the correct results. Okay, here comes the expected result. So the expected result should look something like this. We have a rating, and then its associated average replacement cost per rating. Here comes some hints. The hint is to use the film table and to also recall that average returns back many significant digits, so you can either stretch out the column as you just saw or you can use the round function to fix this issue. And here comes the solution. So the solution is to select the rating column and then apply the average function on the replacement cost column from the film table and then group by rating. As we previously mentioned, the just average function produces many significant digits past the decimal point. So if you wanted to, you could pass this into round and then only select 2 places past the decimal. And here's our last challenge. We're running a promotion to reward our top 5 customers with coupons. What are the customer IDs of the top 5 customers based off total expenditure or total spend? That is the actual dollar amount. All right, here's the expected result. So the expected results are these 5 customer IDs, and here are their total amount expenditures. This should feel pretty familiar. We did something very similar to this during the actual lectures. Here are some hints in case you need them. So the hints are to use the payment table and use order by. And recall, you can order by the results of an aggregate function. And you may want to use limit to view just the top 5 results. Here comes the solution. So the solution is to select the customer ID column and then take the sum of the amount column from the payment table, group by the customer ID, and then order by some amount in descending order. And in this case, we just wanted the top 5, so we also added limit 5. All right, that's it for your challenge tasks. Hopefully they weren't too bad. Coming up next, we're going to discuss the having clause. I'll see you there. Welcome back, everyone. In this lecture, we're going to discuss the having clause. The having clause allows us to filter after an aggregation has already taken place, so it comes after a group by call. Let's take a look back at one of our previous examples. Let's imagine this very simple query where we're selecting some sort of company column and then taking the sum of the sales column from some financial table where we group by company. So we're aggregating sales per company. Now we've already seen we can filter before executing the group by with a where statement. For example, here I could put a where right before my group by and say where company not equal to Google, because maybe I don't want to include Google in my final results. So that's okay because the company isn't being aggregated in any sort of way. It is in the group by statement. However, it's not having an aggregate function being called on it. So I can use where. But what if we actually wanted to filter based off the sum sales? So keep in mind that since we're calling sum on sales, that's not going to happen until after that group by statement is executed all the way at the bottom, which means we cannot use where to filter based off aggregate results because those happen after the actual where statement is executed. So if after performing the group by and calculating the sum of sales per company, I wanted to then perform an additional filter on that result based off the sum of sales, I could add the having clause. So having allows us to use the aggregate result as a filter along with a group by. So you can essentially think of this as a where statement, but only for something that is being aggregated through the group by. And hopefully you can see that connection quite clearly here. So again, here I'm able to now filter based off the aggregate result of sum of sales in my having clause. So here I'm saying, do the filter of the where, and then after you group by, go ahead and do another filtering where we're having the sum of sales greater than some number like $1,000. So you would end up with a query that looks something like this. All right, let's explore some examples of having in our own database. I'm going to jump to PgAdmin now. All right, here I am at PgAdmin. I'm going to work through a very similar example that we just made up. Let's first check out our payment table. So select everything from payments, go ahead and run this. And we're already familiar with this. We have the customer ID, staff ID, etc. Let's go ahead and take the total sum amounts for a customer. So we'll say, select the customer ID, and then take the sum amount from payments, and we will group this by customer ID. So we can run this, and this all works out fine. I already know that if I, for some reason, wanted to filter out certain customers, I could say something like this, where customer ID, and maybe I wanted to say not equal to, or I could say something like not in some list of IDs. Like, let's go ahead and remove 184, 87, and 477. We run this again, and no problem, you saw that now those no longer exist here in the results. Now what I cannot do is filter with a where statement on sum amount, because the sum of the amount is not going to happen until after I call the group by. So what I'm going to do then, let's go ahead and remove this where example to simplify things. I can say after the group by, having sum amount, and let's just say greater than 100. So we go ahead and run this, and we can check out the results here, and now you'll notice everything's been filtered, so all the sums are now greater than 100. You should also notice, just like when we were using order by with an aggregate function on a column, we have to actually specify some amount. We don't just say amount. Let's explore using having with a count call instead of just a sum call. We can do this by maybe exploring the customer table. Just to remind you, we'll select everything from customer table. So this is the customer ID, a store ID, first name, last name, their email, address ID, etc. So what we can do here is, let's imagine we wanted to know the number of customers per store. What I could do is, if we scroll over here, grab the store ID and then count the number of customer IDs associated with them after I group by store ID. So we're going to say store ID and then count customer ID from customer after I group by store ID. We run this and I can see the total count of customers per store. Keep in mind, I don't have to actually pass in customer ID because this is just saying how many rows are there per store ID. So I could put an asterisk here, run this again, and you'll notice I get back the exact same results. Now let's imagine I wanted to select only stores that had more than 300 customers. Well, in this case, I'd have to filter based off something that's already been aggregated. So I can't do that with where, but I can do it with having. So I can say having a count asterisk greater than, let's say, 300, and that's essentially performing the filter after the group by. And keep in mind, depending on how you want to think about this, you can switch out an asterisk there for customer ID, and it will perform the exact same. So customer ID, run this, we get back the exact same results. It's up to you which one's easier to read. Here, if you come back to this quite clearly reads as number of customers grouped by store, where the number of customers is more than 300. If we just left an asterisk there, then we'd have to remember that the customer table represents all the customers per store there. Okay, so let's go ahead and test your skills. In the next lecture, we'll give you some challenges with the having clause. I'll see you there. Welcome back, everyone. In this lecture, we're going to give you some challenge tasks that focus on the having clause. As always, we have the challenge, the expected result, some hints in case you need them, and then the solution. Let's get started. We are launching a Platinum service for our most loyal customers. We will assign Platinum status to customers that have had 40 or more transaction payments. What customer IDs are eligible for Platinum status? Okay, here comes the expected result. So the expected result are these three customer IDs. And if you want, you can also show how many transactions they had. We can see here that there's 3 people that have had 40 or more transactions. Here's some hints in case you need them. So the hint is to use the payment table and to recall that any column can be passed into a count call. Coming up next is a solution. So the solution, pretty straightforward here. We're going to select the customer ID, and then we're going to count, and you can either pass in a column here specific to the amount or just pass in an asterisk. And then we're going to grab this from the payment table, group by the customer ID, and then we're going to say having a count greater than or equal to 40. Essentially answering the question that they've had 40 or more payment rows associated with that particular customer ID, thus earning them that Platinum status. All right, your next challenge is to answer the following. What are the customer IDs of customers who have spent more than $100 in payment transactions with our staff ID member number 2? Again, that's customer IDs of people who have spent more than $100 in payment transactions, but only with the payment transactions that occurred with the staff ID member number 2. Here comes the expected result. So there should be only 5 customers that have done this, and then here's the associated sum. So they're all over $100 here. Upcoming are some hints. So the hint is to use the payment table and to remember to use the where statement to first filter based on the staff ID column and then use the group by clause. And then finally, let's see the solution. So the solution, here we select the customer ID and we take this sum of the amount in order to calculate who has more than $100 from the payment table. We first, however, filter where staff ID is equal to 2. That way, when we do the group by on the customer ID, we're only considering people where the actual payment transaction occurred with the staff ID equal to 2. And then we check for having a sum amount of greater than 100. All right, and that's it for your challenge tasks. I'll see you at the next lecture.